Welcome back everyone to Learning by Teaching. We're in statics and now we're gonna move on into chapter 5, okay? So we're gonna do problem 5.10. Determine the components of the support reactions at the fixed support A on the beam, okay? So we have this beam over here that is supported by our fixed support at point A, okay? So we have a 6 kilonewtons that's going down, and we also have this 4 kilonewtons that is going right and down, okay? So in order to do this problem and know the reactions that this point A is doing, at point A is doing, we need to redraw our free body diagram showing all the forces in with all the reactions. So our beam looks something like this, right? And we will have more forces than only these two. Which forces am I talking about? Well, since this is a fixed support over here at point A, this fixed support can be replaced with a Y force, X force, and a moment. What are the directions? I don't know yet, but I usually tend to assume that my forces, for example, my A in the Y direction is positive, so it's going up. Same for my force reaction of A with respect to the X direction. I tend to assume that it's going to the right. Now, about the moment, I also tend to assume it's positive, so it's going counterclockwise. So this is my moment that my support A is producing, okay? Now, we still have our 6 kilonewtons over here, and we have our 4 kilonewtons over here, okay? We know that from this force related to the x-axis is 30 degrees, okay? And that this plane, this part of the beam is also 30 degrees with respect to the x-axis, okay? Now, if I want to find ax, ay, and the moment with respect to a, which are three unknowns, I have to do three equations. Well, which equations are we going to use? We're going to use the summatory of forces in the x, summatory of forces in the y, and the summatory of moment. So it's something we've been doing all along. So let's start with summatory of forces in the x direction, okay? So which forces act on the x direction? So according to this diagram, we have ax, so the reaction of support A in the x direction, plus the x component of these 4 kilonewtons. Well, how much is that x component? Well, it's going to be 4 multiplied by the cosine of 30 degrees, okay? And all this should add up to 0. Why 0? Because my beam is now moving, okay? So if we solve for ax, we'll find out that it's going to be negative this. So if we found it in the calculator, we use our calculator, we do 4 multiplied by the cosine of 30 degrees, and that gives me 3.46. Okay, so we found out that this is going to be 3.46 kilonewtons. Okay, now, why is it negative? It's negative because the actual direction that I draw my free body diagram is not the correct one. So whenever I assume a direction and it gives me a negative answer, it means that actually this reaction is doing a force opposite to what I draw my free body diagram, okay? So we found our first reaction. Then let's do the same. We're gonna do the summatory of forces, but in the y direction this time. And what do we have? So we have positive ay because it's going out according to our drawing. Then we have negative 6 kilonewtons. So negative 6 minus the y component of these 4 kilonewtons force. So minus 4 multiplied by the sine of 30 degrees. Okay, and all this should add up to 0. Okay, so if I solve for ay, I'll find out that this is going to be 6 plus 4 sine of 30 will give me 2. Therefore, ay will be equal to 8 kilonewtons. Okay, and there we go. We found our reaction in the y direction. Last, we need to find what is the moment at our reaction, our fixed support. So we're gonna do the summatory of moments at which point do you think we should do a moment? Well, the most important moment that we can do at any point will be at point A. Okay, why at point A? It's because if I do my moment with respect to my point A, all these forces, so AX and AY, will cancel out. Why? Because moment is force times distance. And since there is no distance between AY and AX, so that's why I choose the summatory of forces with respect to my A point, okay? My point A. So I'll have moment A positive, because I draw a positive, so counterclockwise, minus the moment that this 6 kilonewtons is producing, which is 6 multiplied by the distance. Well, what is the distance between A and the 6 kilonewtons? Is going to be 1.5 meters. What else? Now, this one, we need to decompose it into y and x direction. So I'm gonna redraw it so it makes it easier for us. I'm gonna do it with the screen marker. So we'll have a negative, that it will look something like that, and we'll have an x that will look something like this. Okay? So let's just start with the y component of that 4 kilonewtons. Okay? So that y component is going to push my beam like this. So it's going to create a clockwise, so negative. What is the amount of that force? Well, that amount of that force is going to be 4 sine of 30. So 4 multiplied by the sine of 30 degrees. And we need to multiply by the distance. Well, what is the distance between this force and my point A? Well, let's look it over here. So this force will look something like here at this point. So if we checked it out, it has 1.5 meter plus 1.5 meter plus this amount that we don't know yet. Well, but we know that if we draw a similar triangle, so let's draw the similar triangle over here, we have that the hypotenuse is equal to 1.5, and we know that the angle is 30. And if we want to know the adjacent, we need to do hypotenuse multiplied by the cosine of 30. So we're gonna do 1.5 multiplied by the cosine of 30 degrees. Okay, so this is probably the most tricky part of the problem. Now, what about the x component? My x component is also going to be negative because it's gonna produce a moment that is clockwise. Now, how much is the x component of that 4 kilonewtons? Well, it's going to be 4 multiplied by the cosine of 30 degrees multiplied by the distance. Well, what is the distance between the force that it's applying in this direction and point A? Well, the distance is this y component of this triangle. So it's going to be 1.5 multiplied by the sine of 30. So 1.5 multiplied by the sine of 30 degrees. Okay? And all this should be equal to 0. So basically, if we solve for moment A, so this guy, which is in this direction, that will be equal to the addition of all these guys up. So let's see how much that is. And we use our calculator for that. So first it's going to be 6 multiplied by 1.5. Then we add 4 multiplied by sine of 30 multiplied by 1.5 cosine of 30 degrees plus, oh, I did a mistake in here, didn't I? This guy is my y direction. We will have to add 3 meters plus this amount. So I need to add 3 meters in here that we have before. Okay. So this is going to be, so we do 4 multiplied by the sine of 30 multiplied by 1.5 cosine of 30 degrees plus 3 meters that we had before. Okay. Then we're going to do plus 4 cosine of 30 degrees multiplied by 1.5 sine of 30 degrees. And that gives me a total of 20.2 kilonewtons per meter. And we found our moment. Okay. Thank you guys for watching. If you guys have any questions or any comments, just post it down below and I'll see you guys in the next video.